and Whisker Plot. We're going to focus on 3 ways that we can go ahead and visually present a population, a data set. And one of the most common ways that we can present it and then use comparisons for it is a box and whisker plot. So what I want you guys to do right now is you're going to draw a number line. And when you're drawing your number line, please make sure that you have equal spacing between each of your values. So my first number here, I'm going to put a 5. And then I'm going to make sure that I am equally spaced apart every single time that I'm drawing my new line, right? I don't want to make them too close together and then too far apart. I want to make sure that they have relatively equal spacing apart. Okay, so my number line starts at 5 and I wound up going up to 80 based off of how far apart I was able to spread the numbers. Now when I'm drawing my box and whisker plot, I want you guys to go ahead and start your start 1 dot at the 10. Let that dot travel all the way to the 20. And then at the 20, I want you to start a box. And let the box end at the 35. So you have a box that starts at the 20 and it ends at the 35. And then from that box, I want you to extend a line all the way down to the 65 mark. So again, you're going to have a dot starting at the 10. You're going to have a box that starts at 20 and ends at 35. And then you're going to have another dot all the way at 65. And you're going to connect those dots to the box. Inside the box, you're going to draw another vertical line right at the 30. So it almost looks like it's splitting the box into 2 unequal segments. This is called a box and whisker plot. You have a box that's representing an interquartile value, and then you have these whiskers that are branching out to your maximum and your minimum value. Maximum being your largest number and minimum being your smallest number. So when we're looking at a box and whisker plot, I don't know what data was used to create this. I don't know how many numbers are in my data set. Maybe there are 10 numbers. Maybe there are 50 numbers. I have no idea how many numbers are within this data set. All I know are a few specific things. I know the smallest number in the data set. What's the smallest number in the data set? 10. 5 is my number line. My number line is just a means to plotting. The data set is based off of the box and whisker plot. The plot starts at 10. So I do know my smallest number. So go ahead and right now in pink, I want you to highlight that small number. And above it, just go ahead and write smallest. So I know, based off of this picture, I can tell that my smallest number or my minimum value My smallest number is going to be equal to 5. I know my smallest value. Do I also know my largest number? Yeah. What is it, Amir? Not on the line. I mean on the graph itself. 65. So in my data set, the data set that I don't know, I have no idea what the data set is, but I do know that the largest number in that data set is going to be 65. So I'm going to write that down. I'm going to put down that the largest number is equal to 65. I also happen to know the median. The median is the very center of my data set. Now, if I'm looking at this, does this picture look symmetric? And by symmetric, I mean if I were to cut it in half, is it a mirror image on the left and right side? No, right? This whisker is significantly smaller than this whisker, isn't it? Same thing for the box. The left side of the box is larger than the right side of the box. It's not symmetric. So when we're talking about the median, we're not talking about the middle of the picture. We're talking about this line right here. Inside of the box, that line represents the median. I'm going to highlight that one in blue. And above it, I'm going to write median. The line inside of the box for a box and whisker plot represents the median for your data set. So the median happens to be at 30. So I know my median is 30. I also can tell the range. Because I know what my smallest and largest numbers are, the range is how far your box and whisker plot is going to extend. So starting at your smallest and ending at your largest, I just highlighted that in orange, that's going to be the range of your data set. So what is 65 minus 10? I asked a question. Come on, guys. 65. Thank you. Whew. Scared me for a second that you don't know 65 minus 10. So the range is how you extend the entire chart. The entire graph is going to be considered your range. There's one other value that we know that we haven't talked about yet, and that's called interquartile range. Now, the interquartile range, we're going to go ahead and from this point on, we're going to label it IQR, just so it's a nice little abbreviation. So the interquartile range is very similar to what we know as for range, but instead of it being the range from whisker to whisker, it's the range from the start of the box to the end of the box. So the start of the box to the end of our box, that's going to be your interquartile range. And I'll write that up here too, IQR. At the very start of your box, all the way to the very end of your box. So our box starts at what point? What point does our box start at? It starts at 20 and it ends at what? 35. So we can do 35 minus 20, and the interquartile range is 15. Joseph, stop, baby. Interquartile range is going to be 15. Tamari, are you okay?
He's calling me white.
Okay.
You just took it to another level.
All right, so based off of this chart, this this plot, the box and whisker plot, guys, this is the only information that we actually know. There isn't anything else that we can tell. We cannot tell what the mean is because I don't know, how many numbers are in the data set. I don't even know what the specific numbers are in the data set. So I can't tell you what a mean is. I can't tell you what the mode is. I don't understand why you guys are still talking. Take your hood off, Jaden. So you don't know what the specific values are in the data set when you are given your plot. What you do know is just the range. So a box and whisker plot is a really great representation for what's called variability, identifying variability of a data set. Variability means how spread out or how compact is your data. Now, looking at each of these segments, this is actually splitting your data set into what's called quartiles. So when you hear the word quartile, what word do you think of? Quarter. Okay, so I'm going to go with Aiden, who had said quarter. Okay. Quartile, quarter. What is a quarter? 25. So a quartile breaks your data set up into 25%. So each of these sections, there are 4 sections. The section that is from your smallest to your what's called your first quartile, the smallest number to what's called your first quartile or the start of your box, that's 25% of your data. So I know that 25% of my numbers, whether there are 10 numbers or 20 numbers or 2,000 numbers, 25% of my numbers in my data set belong between the values of 10 and 20. They are somewhere between 10 and 20. One of them is definitely 10. The next 25% is between the start of my box and my median. That's the next 25%. The next 25% is going to be from my median to the end of my box. That's also 25%. And then the last 25% is from the end of my box all the way to the largest part of my data set. Now look, are they equally spread out? No. In fact, this third section is the smallest section, but it doesn't mean that it doesn't have the same amount of numbers. If there are 20 numbers in my data set, then 5 of the numbers are going to fall between 30 and 35. That means I might have some repeats. I might have a mode in here somewhere. Okay, it all depends on how big my data set is. Let me show you what I mean visually if you're looking at it as a visual representation. So let's say that I happen to know my data set and I'm going to go ahead and plot it. My data set might be 5, 5, 10, oh, sorry, not 5, sorry. 10, 10, and we'll say 15, 17, and 20. Okay, then the next set might be a 20 and a 24, 25. We'll say 29 and a 30. And then we've got another set that's going to be 30, 33, 33, 33, 35. And then we've got 35, we've got 52, we've got 61, we've got 64, and then 65. So looking at this, that's 20 numbers in my data set. When I say that there's 25% of my data set is in this first section, that means right here, these first 5 numbers, 10, 10, 15, 17, and 20, those numbers belong right between here. That's my first 25%. Then my next 25%, from 20 to 30, these numbers right here are going to belong in this next section. That's 25%. Then the next set of numbers from 30 to 35, I'll have a whole bunch of repeats here. I have a whole bunch of repeats because that section is so much smaller. And then the last section, look how spread out this data is, 35 all the way up to 65. I have a lot more differentiation between these numbers. So but that also is considered 25% of my data set. So when you're breaking it down, you're breaking it into these segments. That's what a box and whisker plot does. It shows you your range. It shows you symmetry versus non-symmetry. Let's take a look at the next type of data set that you can see. And you saw one today already when we went over it on the interim. A dot plot. Go ahead and get this copy down. All right, get that copy down. While you're getting it copied down, for here, when we're looking at a dot plot, okay, dot plot could have either X's to represent the numbers or it can have the dots to represent the numbers. But based off of the dot plot, let's go through those measures that we've talked about before. Looking at this, could I calculate the mean? Raise your hand if you think that we can calculate the mean when looking at a dot plot. Okay, raise your hand if you think that you could not calculate the mean when looking at a dot plot. Braxton, what do you think? No. Braxton, what do you think? Do you think we can or cannot calculate mean by looking at a dot plot? Why? You're right. Let me tell you that you are right. So whatever made you think yes, what made you think that? It's a guess. Okay. Braxton, how would you calculate mean? How do we calculate mean? How did we calculate mean? We added them all together and counted how many there were, right? Do we know what each of the numbers are? Yeah. How many 6s do I have? 2. How many 8s do I have? 0. I don't have any 8s. How many 10s do I have? 5. So I know that my data set is 6, 6, 7, 9, 9, 9, 9, 10, 10, 10, 10, 10, 11, 12, 12. I know what my data set is. So can I calculate mean if I know what the numbers are? Yes. Can I calculate median if I know what the numbers are? Yes. Can I calculate mode? Yeah, mode is easiest, isn't it? Look for where there's the largest amount of X's. There's your mode. And can I calculate range? Yes, because I know what my smallest number is and I know what my largest number is. So these are things that you can calculate. When you have a dot plot, you can calculate everything. You can actually calculate everything with a dot plot. So let's go ahead and do that right now. I want you guys to go ahead and calculate the mean of this dot plot, then calculate the median, then the mode, and then the range. Go ahead and do that right now.